number one is this one. Okay. All right. So okay. So the problem number one, we have to find the force of friction. So we have to find the force of friction. So we have a box. We have a box here, and there is a applied force. Applied force is, of course, applied force is given, and that is 50. So applied force is 50 Newton. And then we have to find the force of friction. Force of friction. We have to find the force of friction. What else is given? What else is given? Given is the acceleration. Acceleration is 10 meter per second square to the right. To the right. So the net force is to the right. Net force is also to the right. Now, how can we find? And also the mass of the box is given. Mass of the box is 4 kilogram. Now, there are two ways to find the force of friction. Force of friction is mu Fn, and force of friction is also F applied minus F force of friction. So force of friction is then applied force applied minus F net. So we have two equations which we want to use. All right, so this one will not be, we cannot use this one because mu is not given. So we're going to use this one. To use this one, we have to first find the net force. So let's first find the net force, F net. So F net is ma. So F net is m is 4 kilogram and a is 10 meter per second squared. So F net is equal to 4 times 10, 40 Newton. Okay. All right, that's then we're gonna have to do is step number two. Step number two, you have to find the force of friction. So force of friction is equal to F applied minus F net. So force of friction is then F applied is 50 Newton minus F net is 40 Newton. So force of friction is 10 Newton. So the answer to question number two is 10. Question number one is 10 Newton. So force of friction is 10 Newton. Now we're gonna do question number two. To do the question number two, let's get the question number two first. So all right. So what do we see? We see that there is a box and the two forces acting on the box. So let's first get this straight. So this force is acting to the left. So this force is acting to the left. So 6 Newton is acting to the left. So we're gonna write 6 Newton. All right, and 10 Newton acting to the right. So we're gonna write 10 Newton. 10 Newton. Now, in order to get the equilibrium means net force is 0. In order to get the equilibrium at the x direction, we have to make the net force 0. So how much force we have to add? We have to add, in order to get the net force 0, we have to add 10 minus 6, 4 Newton. 4 Newton to which direction? If we do add 4 Newton to this direction, then it's gonna be, it's not gonna make it equilibrium. So you have to make the additional 4 Newton to this direction, and that 4 Newton. Now, the new scenario would be uh, 10 Newton, 10 Newton to the right and 10 Newton to the left. Make it equilibrium because net force is 0. So the answer to the question is 4 Newton to the left, 4 Newton to the left. Thank you.